I want to welcome you all. So to make this webinar easier, I have sent the data file and our script file via the email. Please download them so that you can practice with me along this 1.5 hour. So I've sent, I want to show you the folder that I have sent. I have sent a folder named November 7. So there are data files, same data files in different format. One is in Excel, another is R format, another is Stata format. So the same data is different, is in different format in that file, and one is a script file called November 7 and OV7. So I'll show you the link, and so I have sent you this folder November 7. Sorry, just 1 minute. So there are data files, and there is R script called October 27. We will not use that. We will use the R script November 7. So before using that file, I want to introduce the R Studio. So as I said, R Studio is simply an application that makes our life easier while using R. R Studio is not a different program in itself. So if you download and install R Studio only, it will not work, because all the calculations, all the estimations are made in R. R Studio is simply a connecting line only. So you should download R first, you should install R, and then you should install R Studio only after installing the R. So I want to introduce the basic window of R Studio. So I have already saved this work scripts. That's why data are preloaded in this. But if you open R Studio for the first time, you will see this screen, this window. There are three parts. So we call this part R console. All the commands are typed here, and answer comes in this console. So this is called console. So this part is called environment or history. So all the data set, all the graphics, all the estimations are saved here with some names. We'll give some names. For instance, if we run a regression, we will save the regression by giving some name, and the name will appear here. If we import some data, the name of the data set will appear here, and the basic information will appear. The history part captures all the things that we done. For instance, all the commands that I run in this R Studio have been saved here. So you can recall the commands. If you forget some, you can recall from history. So the third part of R Studio, which covers the files, plots, and packages, and help option. So the files option is not that much helpful to us. The plots option, the plots tab will show the graphs that we plot in R. The packages shows the list of packages that we have installed in R Studio or R. The help option shows the help. For instance, if we want to know about the regression command, and if we search here, it shows the help about how to estimate regression in R, how to interpret, etc. So these are the three parts of R Studio. So then the fourth part comes only when we open an R script or a file in which we can type commands and save commands. So I will open the R script that I have sent to you. So that is November 7. So if you open any R script, so the four different parts of the window will appear. The first one is the R script part, in which we type codes. We can save the codes typed in this part, and we can reuse it in the future. So now I have consolidated all the basic things that we will do today in this R script, and I have separated them by topics. For instance, we'll start from the parts of R Studio window that I have just done now. So there are basically 4 parts of the window. The second topic is how to change the font size, how to change the font type, how to change the theme. We can do it simply going to going to tools, and then global options, and then appearance options. So by going to tools and global options and then appearance, you can change the zoom, you can change the font type, you can change the font size, and you can change the theme. For instance, if you do not like a black window, you can change the theme to this one, so that the commands, the background becomes clear, the background becomes whiter. So you can choose among these themes as per your preference. So the font size, if the font size is too small, you can increase the font size from here. You can even change the font type, even change the theme. So this is the second topic that we have covered. So I will set the theme to some contrast theme, so that the commands can be seen more clearly. So the third topic is about the shortcuts that can be used in R, especially in R Studio. You can zoom this for Windows. For instance, if you type Control Shift and 1, so you can see the editor or the R script in full screen. If you press Control Shift 1 again, it will come back to the previous position. So Control Shift 2 will zoom the R console, and Control Shift 2 again goes back. Control Shift 6, it zooms the plots or graphics that we have made. So again, Control Shift 6, it takes it back to the initial position. So you can see the shortcuts that I have typed here, and you can try in your R Studio. So 2 more shortcuts that will be helpful to us if we write any command and that we will going to execute. For instance, if we write 2 plus 2 and we want to execute it, we want to run it. So the command for it is Control Enter. So Control and Enter buttons runs any command that we have selected. So you can run a command by clicking this run button, by just hitting this run button, or just pressing Control and Enter button. And to save the R script, you can simply Control and S. You can press Control and S. So these are a few shortcuts that makes our life easier. So now R is extended. R has been extended. It's the data analysis power in the form of packages. Packages are simply the collection of functions that have been constructed by the people like you and me. So even we can build some packages by typing some functions, and we can send the package to the CRN server, and people can use our packages. So to see what packages have been installed by you, you can just simply type this in our studio, install.packages, then bracket open and close, and you can run it. So to run this command, as I said, you can just press Control and Enter. You can just press Control and Enter, or you can hit this run button. So I press Control and Enter, and it shows all the packages that have been installed by me. So it shows all the packages that have been installed by me. So you can try it in your R Studio to see what packages have been installed by you. So the library, if you type library, bracket open and close, and run this by control and enter, you can see the same commands but in a different file called R packages available. So now to install a package that you want, you can do it in different ways. You can do it in R script file or in R studio simply by typing install.packages. For instance, I want to install a package. I will type install.packages, then bracket open the name of the package inside the inverted commas. So for instance, I want to install a package called Plotrix. So I write install.packages, bracket open, then name of the packages within inverted commas. So then you can run it by pressing Control and Enter. So it will install this package in your computer. So you can install this package through the Packages tab on the right bottom. So Packages tab, then you can hit install, then you can type the name of the package, for instance Plotrix, and you can select it, and then you can press or you can hit install button, and it will install the Plotrix package in your computer. So which package to install can be broadly found in the Google. So you can type in Google if you have to estimate some type of test, for instance ANOVA. You can type in Google which package is useful for doing ANOVA, and you can find the name and you can install that. For instance, I have installed a lot of packages for today's webinar, and you can install them one by one, or you can install them all at once. If you want to install more than one package, you can separate them by commands. For instance, I want to install two packages, AER and readxl. So I write install.packages, bracket inverted commas, AER comma inverted commas, readxl. So if you wanna install more than two packages, you can even then combine with the combine function. So I hope you can install these packages and do practices. The easiest way to install package is the GUI. From the GUI interface, you can go to the Packages tab on the right button, and then you can click install, and then you can type the name of the packages and then install the desired packages. So the fifth one is not necessary. I think if you have installed the recent version of R, it's not necessary to update. But if you have the older version, you can install the installer package, and then you can run the command update R. So I have the latest version of R, so this update R will not add anything extra in my R studio. So the sixth topic that we will cover is the concept of objects. So one extra thing in R, I think, is the concept of objects. So in R, everything that we do in R studio is saved in the form of object. For instance, if we type a vector, it's a save as an object. If we type a single value, it's a save as an object. For instance, if I type x1 equals to 2, the R Studio saves it as an object named x1. For instance, if you click this line and press Control Enter, you can see the name of the object in Environment tab. It shows that the name of the object is x1 and its value is 2. So the x2 object is simply the vector. So if you write C means combine. So what this command tells us is that combine the number from 1 to 20. So x2 is an object that combines the number from 1 to 20. So if we press Control and Enter, this command will be run, and the x2 objects comes up here. So we have to understand that everything in R is saved as an object, whether that is a variable, whether that is a data frame, or that may be a t-test, that may be an ANOVA test, that may be a regression output. Everything is saved in the form of object. So to see the component of the object, we can simply type the name of the object. For instance, I create an object called x2. The x2 object contains the number from 1 to 20, and I want to see what numbers are inside the object x2. So I type x2 and I run it by pressing Ctrl Enter, and the console shows the answer. The console shows that inside x2 you have the numbers 1, 2, 3, 4 to 20. So everything in R is saved as an object. If I create a matrix, it's an object in R. So I can see what's inside the x3 object, and it will show that x3 is a matrix and its values are from 1 to 16. So these objects can be cleared by using the brush button that you can see on the right top just below the connection tab, or you can just remove the objects by typing remove. For instance, if I want to remove x3, I can type remove and then the name of the object x3. If you run it, the x3 object will be removed. So the shortcut for remove is rm. If you type rm and the name of the object, it will remove x1. And if you type rm and then x1, it will remove the object x1. So objects can be cleared by just typing rm and then the name of the object inside parentheses. So the next topic is the assignment operators. So the assignment operators helps us simply to define the values of the variable, simply to define the object. For instance, if we want to create a vector and name it, the assignment operator shows that we want to assign the name x1 to that vector. We want to create a data frame, and the assignment operator gives us a name. For instance, I want to assign the value 12 to the object x1. So the assignment operator simply attaches the value to that object. So assignment operators may be used in different ways. The most common is less than and hyphen sign. So what this assignment operator shows us is that we simply assign the value 12 to x1. So if we run this, what R understands is that 12 has been assigned, or 12 has been attached to the object x1. So if we type x1, it shows that the value of x1 is 12. So assignment operators can either be created by using smaller than and hyphen sign. This is the most common one because it's used in other programming languages also. So people use less than or less than hyphen sign. But the sign equals to also works perfectly. So you can use either. You can use either less than a hyphen sign, or you can use equal sign. For instance, I have shown here two examples. Both works perfectly. The first instance is x1 less than hyphen 12. So R understands is at the value of x1 is 12. The second one is x2 equal to 12. So R understands that value of x2 is 12. So if you type x2, so R shows that its answer is 12. So if you want to create anything, if you want to create a data frame, if you want to create a graph, if you want to create a table, you can name the table by using the assignment operator. So it's useful because we want to save the graph by naming it. We want to save the regression result in some name. We want to save other regression outputs by naming them. So it may be useful. The assignment operators may be useful. So we just summarize this section by re-emphasizing that the assignment operator can be used by two symbols. The first one is less than and hyphen sign. The second one is equals to. Both works perfectly, but the most common one is less than and hyphen sign. So you may practice the assignment operator by using less than and hyphen sign. So I have given many examples. For instance, I want to create a vector that has two elements, 10, 20, and assign that vector to the name x21. So if I run this, the x21 vector can be seen in the environment tab, the name of the objective x21. So if you want to see what is inside x21, you can just type its name, and the message says that object not found. Because R is case sensitive, I have put the small x1, small letter x1, x21. So I should type small x21 to see what is inside x21. So if I run this, it shows that there are two elements. So the assignment operator is simply less than and hyphen sign, or you can put equal sign. So the next one is about how to clear objects from R. For instance, in my screen, you can see 4 objects, x1, x2, x2, and x21. So you can see 4 objects. If you want to clear all of them, you can use this brush sign, or you can simply remove them individually by typing remove and the name of the object inside parentheses, or you can simply type this command. It clears all the objects. It clears everything that is in the environment. So this is rem. Rem is for remove. Rem is for remove. Then parenthesis list equals to ls. So this list equal to ls, it ignites it, or it indicates all the list of the objects, and the rem removes all of them. So if you run this by typing control or by pressing control and enter, it clears all the objects from our environment, from our art studio. So I want to move to next part, data types in R. This is rather easier, so I won't spend much time here. We can differentiate between different type of data. For instance, if the X object has a single number, we call it a scalar. X has a single value called 4, so it's called a scalar. And if we combine numbers in some order, we call it vector. So the A vector is A vector contains number from 1 to 3. So if I run this, A object comes up here that has 3 elements. So the vectors can be even made from words. For instance, I can create an object called B that is a vector and has 3 elements, 1, 2, and 3, and I can create C element by just putting the 3 elements inside the vector. So one is scalar and another is vector. Vector has numbers, vector has words arranged in some order. The third type is data frame. Data frame is just like you use data in Excel that has some variable names on the top, that have some observations in the main part. So that's called data frame. So the data frame looks like just like this. So I have created a data frame that has some rows, variable names, and that has some numbers in its body. So another one is matrix. So since matrices are not useful for data analysis a lot, I want to spend time here. You can run this command. It should work in your computer. You can run this and see the matrix. For instance, if you run this and if you see the mymat matrix, you can see this matrix. So this is another data type. So you can see another matrix also. So another type is list. So list contains uh, list contains objects of various natures. So list may contain a data frame, list may contain a matrix, list may contain a graph. So various nature of objects can be saved in a list. So few minutes about the sign of mathematical operation. So for addition plus operation plus sign is used, all the signs are uniform across all softwares. For multiplication, asterisk is used. For division, forward slash is used. So for power function, you can use double asterisk. So 2 double asterisk 5 is 2 to the power 5. So even you can type this sign for raising 5 to the power of 2. So you can calculate a square root by just putting 0.5 in the power. So one useful thing is the log. So if you type log 100, it calculates the natural log. So this may be useful while calculating regression. Specifically while calculating regression, this may be useful. So to log transform a variable, we simply type log and inside the parenthesis the name of the variable. So to add, plus sign is used. To subtract, minus sign is used. So these are useful while transforming the variable. So there are some built-in data in R. Let me move to topic 11. There are some built-in data that you can use to practice the data analysis commands. There are inbuilt data you can see by running this command. If you type data and then bracket open and close, so you can see a list of data set that is built in R. So there are a lot of data set. For instance, you can use the car data set that's available here, that has been used by many people around the world. You can use the inbuilt data set. So to use this car data, you just type data and inside the parenthesis you can type cars. So this loads the data set car in our environment, and you can do analysis. You can make graphs, so you can calculate hypothesis, statistics. So to view the dataset car, so you can just type the name of the dataset and press Control Enter, and then you can see that this dataset consists the speed and distance of cars, and it has 50 observations only. So there are other built-in data sets that I have shown to you. You can try other data sets. You can summarize them. You can plot graphs from them just to learn the commands in R. So the next topic is how do we find help in R. So the help function helps us to find to know something about the R functions. For instance, if you don't know how to calculate mean in R Studio or mean in R, you can just type help and then inside parenthesis mean. If you enter this, Control Enter, if you press Control Enter, so the help tab, it opens and it shows what are the options that can be used, and it may show some examples too. So this help function can be used with a question mark also. For instance, if you type question mark and mean, it will open the same help window. So for instance, I put question mark and t-test, so it will open a window in the help tab about t-test. So it will show the options in t-test, various options in t-test, and it may provide some examples too about how to use these functions. So you can find help about any functions. For instance, I have typed few examples here. If you want to know about how regressions are estimated, you can type help and then inside parenthesis lm. So this shows the help about estimating regression and interpreting the regression results. So if you want to know about the options in some packages that you have downloaded. So, you must type library and then parenthesis help equals to the name of the package inside the parenthesis. So if I press Ctrl Enter, it will open the help file of the ggplot package, and it will show what are the options that can be used in the ggplot package. So it will show what can be done with this package, what are the options, everything about the package. So if you want to take help about some packages, simply typing question mark and the name of the function will not help. So you should type library and inside parenthesis help equals to the name of the package inside the parenthesis, sorry, inside the inverted commas. So the next part is about manually entering the data set in R. So you can manually type data set in R. For instance, if you have a very small data set that you can type manually, it's useful. You have large data set, manually typing is not useful. So you can try these functions. So I have created a variable ID. So this is assignment operator. You can just read this as id equals to id equals 1 2 and 3. So combine 1 2 and 3 means id has three elements, 1 2 and 3. Gender has three elements, male female male. Age has three elements, 25 26 and 52. So if I create this vector, the next one, if I type information, for instance, suppose that there are only 3 people whose data I have to enter, I can use this approach by manually entering the data set. So I have typed their gender, I have typed the information about the age, and then I'll combine the information in a data frame. Then I will look the data frame. The name of the data frame I have created is data1. So if I view data, so the data will open in a different tab. So the data frame has 3 individuals and it records the information about the gender and age. So for small samples you can manually enter the data set, and for large samples I do not recommend. In fact, no one recommends typing them manually in R. So this manual data can even be entered by using by creating a blank data frame and then entering. So the blank data frame can be entered or can be created by simply uh, using the data frame command. So the name of the data we want to create is data2. So this is the name of the data frame. We want to create a data that is named as data2, and that equals the data frame is the name of the command. So name is the first variable, which is a character variable. So we type characters like ABC here. So we give the structure of the data, structure of the variable name as character. Then id is in number, so we write id equals to numeric variable and parenthesis open close. And gender is numeric, we code gender as 0 and 1, and age is numeric. So if you run this, it will create a data frame, blank data frame, and then you can edit it by using the edit command. So if you run this, a new window will appear and you can just press the data here. You can type the data here. So 1 2 3, sorry, this is the name. So for instance, John Adams. So you can just type data manually here. So id is 1 2, gender is, we will code gender as 0 and 1 because we have told R that it's a numeric. You cannot type character here, so you can type on the number. So 0 is for male, for instance, 1 is for female. You can type numbers only. So age is, for instance, 25 35. So in this way you can type the data set manually in R. So we will move to the next part, setting the working directory. So working directory is simply the folder in your computer in which all the data that we will use are put and all the estimations are saved. So if we tell R that this is my working folder, R will import the dataset from that folder and it saves all the outputs in that folder. So for today, I have created a folder called November 31st in my desktop. So this is the folder where I have put all my data and I want all the R outputs to be saved here. For instance, I have exported regression results from R, which is inside reg.doc. So this is a file created by R. So I want all the output to be saved in this folder. So this folder is then called working directory in the language of R. So to set the working directory, we just keep the data in a folder and we open that folder and we click the address bar. We click the address bar to see its address. So we copy that address and we paste it here. So inside the inverted commas, so we paste the path of the folder. So one minor change we have to make here is that we have to convert the backward slash to forward slash. So we have to change the backward slash to forward slash. If we use backward slash, our may not work. So we have to change the backward slash to forward slash. If you change this working directory, all the commands that I have sent to you should work in your computer perfectly. So the only thing that you should do to run the commands sent by me is to set the working directory in R. So this can just be done by copying your folder address. For instance, I have sent you the folder called November 7. You can download that folder. You can put that folder by unzipping in your desktop, and then you can open that folder and you can click the address bar and copy the address of this folder and then typing this into the R script. So you should change the backward slash to forward slash. So if I run this, the working directory will be shown here. So in the console, at the top of the console, the address of the working folder is shown. So it's a C user Siddha desktop October 31. So if you can change the working directory here, if you can replace this address by the address of your folder in your computer, all the commands that follow this line will work perfectly for you. So this working folder can be set manually too. So if you go to Files tab, to set the working folder manually, so you should go to Files tab, on the right button Files tab, and then you should click the more options. So you should go to Files and then more options, and then you should choose the option set as working directory, or you can go to the working directories to see that which folder is your working directory. So you can just press the copy the address bar and paste here and change the backward slash to forward slash, or you can set it manually too. So I think you can change the working folder. The only thing is to change the backward slash to forward, and another thing to remember is that you should put this inside the inverted commas and inside the parentheses. So if you run this, then the address of the working folder will be changed. and all the commands that follow this will work. So I want to move to topic 15. If you want to create and save an R script file, how can you create and save? Simply, the R script file is a command file that we can type the commands in that file and we can save it for future use. So to create a command file, you can simply go to file, and then new file, and then R script. So file, new file, and R script, it will open a new R script file. So now you can type your commands here. X1 equals 12, x2 equals to x1 into 10, and you can save this file for your future use. So to save this file, you can simply press Ctrl S, and you can name the R script. For instance, I put it November 7 trial. So if you save this, it will be automatically saved in your working directory. You can see that the November 7 trial, the new R script has been saved. So the advantage of setting a working directory is that if you save anything, it will be automatically saved to the working directory. So you can create this script by simply pressing Ctrl+Shift+N. That is the shortcut. Ctrl+Shift+N will open a new R script file that you can work with. So the next one is how to import data in R. So there are various ways of importing data. I will highlight few methods. The first one is from the GUI interface, just by clicking the import data set. How can we import data in R? So I will clear all the objects first from the environment. So by using this brush tool, so the object list is clear now. So I will import the data set by using this GUI interface. In the environment tab, there is one option called import data set. You can click that option and you can choose the format of your data. You can choose the option as per your format. For instance, my data is in Stata. For instance, I have saved my data in Stata. I can choose the last option, and it will lead to us a new window in which we can browse the name of the file. So if you browse and have set the working directory, it will lead directly to your working directory. And I will choose .dta data file, which is the Stata format. And if you click open, it will preview your data for a few seconds, and then you can click import to import the data. So I will clear this data again, and I will import a different format. So for instance, if you want to import the data from Excel, you can choose from Excel option, and then you can browse and you can select the Excel format data3.xlsx, and it will preview the data, and you can press the import button and it will import the data set in R. So I will close this and I will remove this data file, and I will import from text format. So the text format is .txt data file that I have sent to you, .txt. So if you open this and if you press import, the same data in text format will be imported. So you can import the data set by using the import data set button on the top right. You can do this by typing the codes. So after setting the working directory, you can use these functions to upload the data set. I won't go about the functions in detail. For instance, to import the data set from Excel file, you must have installed the readxl package first, and to import the data set first, you should invoke, or you should bring the readxl package in the memory of R. So to do so, we simply type library, and then the name of the package, readxl. So this package is required in order to import the data set from Excel. So then we put the name of the data file as data file equals to read Excel, then inside parentheses the name of the Excel file with format and the sheet of the Excel in which we have put your data. So if you run this command, it will import the data set. Then I remove this data set and again import the data set from txt file. So to import the data from txt file, we should type read.delim. So this command will import the data set from txt format. So you can see what are the variables in the data set, and you can remove it. Then from CSV file, the read.csv command is used. You can press Ctrl Enter, and a data file is imported in the history. You can remove this data file. And to import the data from stata format, we need the HAVEN Haven library or Haven package. So we first bring this in status or R's memory, and then read underscore DTA command will import the data. So this is the name of the data. This data is in working directory, and you can delete this from the memory of this data. So you can even directly use the data in R format. So if we look the folder that I've sent to you, there is R data called data3.r data. So to use the data saved by R in R data format, you just use load function and then inside parentheses the name of the data. So it will again import the data set. So I remove this, and you can import the data set from websites also directly. So the corresponding commands are given here. The only thing you have to know is the address of the website in which on which the data has been uploaded. For instance, just to discuss here, I have uploaded the data set in my Google site, and if I press this or if I run this command, data set is imported from the website of mine, and I remove this again. So to import the dataset from data format in website, you have again bring the parent package in memory, and first you should invoke this package and then read.dta address of the website and then the name of the data file. This will bring the data from website in RStudio. So I remove this data again, and you can even manually import the data set by using this command. If you run this, it will open a dialog box in which we are asked to choose the data file. So if we choose, for instance, this was CSV, so if we choose CSV file, it will import the data set. So there are different ways to import the data set. You can use the most simple one by using the import dataset tab on the right top, or if you want to type codes, you can type the codes that I have given to you. The only thing that you have to do is to change the working directory, and all commands will work automatically for you. So you can run one by one to see what happens, how dataset is imported from CSV, how dataset is imported from Stata, etc. So you can even export the data set that you have imported in the memory. For instance, we have imported a data set here. We can export it in Excel format. For that, the save function will work. If you want to save in R format, write CSV will work. If you want to write in CSV format, if you want to save in Stata format, you have again to invoke the foreign library. So you can try this one, and after trying this, you will see a different. For instance, I will do one for you. uh, Data, I will name data November 7. What I'm going to do is I want to save this data file that I have imported in my working directory, and the file to be saved is data November, and it is in R format. So if you run this, and if you look at your working directory, you must see a data file. You must see a data file in R format. Let me see. Object data file not found. Save data file. File is 1 minute. Data file not found. Sorry, it has a different name. So the data file imported in our memory is not data file. This is data file manual. So I have to write here data file manual. So the data file has a different name, data file manual. So you can see the name simply from here. The name of the data file is data file manual. So save data file manual as our data. So if you run this, it will save the data in a new format. So you can see in the working directory that the data has been saved in our data format as data node 7. So you can export data by just using save command or write CSV command. So if you want to edit your data, you can just type edit and the name of the data file. So let me delete this and import the data called data file again. So to edit this data file, you can just type edit and the data file name. This is the name of the data, or you can just type fix and then data file. So if you type edit and the name of the data file and press Ctrl Enter, the editor window will open and you can edit the numbers here. For instance, you can put this 10 instead of 3. If there are any missing values, you can replace them by any number, by their means, or any other numbers. So if your data have some missing values, you can fill them, or if there are typos, you can fix them here. So I will remove all the objects again, and for our further purposes, I will import the data file once again. So our data file can be seen by clicking the data file in our object window. So if you look the data file, it has 540 observations, and the name of the variables run from gender, ethnicity, age, and others. So if you have a small data file, you can see them just by clicking the name of the data file. And if you have large data files, just browsing the data file will not be an efficient way. So in that case, you can use these commands that I have sent to you. If you want to see the name of the variables, and then you can type names and then name of the data. So it will show the name of the variables in the R console. So we have 17 variables, and the name of the variables are in the console. So if you want to see the length of the data set of a single variable, you can use length command. So the gender variable has 540 observations. So row names are the numbers or are the names put in the first column of the data set. The column names are the name of the variables. Again, column names and names will provide us the same results, name of the variables. So the dim command gives us the dimension of the data set. If you type dim and the name of the data file, it will show that there are 540 observations and 19 variables, 540 rows and 19 columns. So you can run these commands to look over the data set. For instance, if you want to see the first 20 observation, you can run this and see the first 20 observation. So you can see a single variable by just keeping the dollar sign after the name of the data file. So one problem with R is that it cannot calculate statistical computations if there are missing data. So finding the missing data and treating them can be a first step in our data analysis. For instance, I will import a data set that has missing values and I have sent it to you. So I can use this to see whether there are any missing values or not. So if there are any missing values, it will show true. So this is rather an inefficient way. We can use the sum command to count the number of missing values. So there are 23 missing data in our data file. So if there are missing data and you try to calculate any statistical computation, for instance, I try to calculate the mean value of wage rate, it won't calculate. So it shows that the answer is not available. So if you have missing data, R cannot calculate statistics. So we should tell R that please ignore the missing values while doing computations. So this can be done by adding na.rm equals to true command. So if you run this command, it will now calculate the mean value of the age. It will now calculate the mean value of wage rate. So if there are missing values and you try to calculate statistics, if it says that the answer is not available, so you must just look for the missing values. And you should either add this command na.rm equals to true, or you should delete the missing values. So the next one is the name of the variables, class of variables. So this is easy. If the variable has number, it is numeric. If it has words, its class is simply character. So three types of variables may be used. One is character variable, which are in words. Another one is numeric, which is a number. And the third one is factor variable. I will discuss about the factor variable a little bit later. Factor variable is categorical variable. For instance, gender is a factor variable. Even if it has 0 and 1, it cannot be measured in numbers, so it is in categories that we call factor. So numeric variable, you can check the class of the variable by simply typing class and then the name of the data, dollar, name of the variable. So the gender is an integer because there are 0 and 1. So now we should tell R that this is a factor variable, this is a categorical variable, and R will do the necessary statistical calculations automatically. For instance, we cannot calculate the mean of the gender that is coded as 0 and 1. So we will tell R that it is categorical variable. So R understands that I cannot calculate mean for gender. I cannot calculate standard deviation for gender. So we will basically differentiate between a numeric variable, which is measured in number, a character variable, which is purely measured in words, characters, letters, and we will differentiate about factor variable, which is measured in categories. So the same thing I have put in topic 22. For instance, the gender is categorical variable. So now we should tell R that even though we have put 0 and 1 for gender, this is categorical. 0 stands for female and 1 stands for male. So you can tell R that gender is categorical by running this command. The function is factor function. So after factor, before this is simply the data file and name of the variable equals to the function factor, name of the data file, name of variable, then labels equals to combine 0 1. So the labels are 0 1, these are the numbers in the data set, and we want to attach the categories to these numbers 0 and 1. So we want to attach female for 0 and male for 0. So if you do this, R understand that this is categorical variable and R will not calculate mean for you. So then R will not calculate mean for you. If you want to calculate mean, it says that I want to calculate, this is a string. So I will do it for others too. You can simply just run those. For example, education type, in the data file there are numbers from 1 to 7. So we attach the word professional for code 1, doctorate for code 2, MA for code 3, BA for code 4. So in this way we tell R that this is also categorical variable. So if we run this, the next one is for ethnicity, next one is for marital status, the next one is for employment sector, the next one is for urban and rural, the next one is for region. So if you run all these codes and if you look the data file now, you can see that all the codes have been converted to categories. So the 01 code in gender has been converted to male, female, and in ethnicity it has been converted to white, Hispanic, and black. In education type, converted to codes. In marital status, converted to codes. And in other three variables, it has converted the numbers into codes. So the main benefit of telling R that these are our factor variables, the main advantage is that now R understands these variables to be categorical, and R will not calculate mean and standard deviation, or R will calculate the appropriate statistical measure for these variables. So you can try, for instance, if you want to summarize your data, let's see what R does. So if you want to summarize, the summary function simply calculates calculates 5 statistical measures. Let us see. So the output shows different statistical measure for all our variables. So the gender is categorical variable, so it has not calculate mean and median for this. The ethnicity is categorical, so R has not calculated mean and standard deviation, mean, median, quartile for this. So for age, since age is numerical, R has calculated the necessary numerical measures. So the advantage is that if we tell the categorical variable to R, it won't calculate mean and standard deviation, which do not make any sense. So for all other variables, if they are categorical, only count is given. If they are numerical, the 5-point summary is given by R. So it's beneficial for us to tell what are our category variables and what are the numerical variables. So the next function discusses about how can we subset the data, or how can we extract part of the data set from RStudio. Okay, so subsetting command is simply to extract a part of the data set. So the basic syntax we have to understand here is that, for instance, we have to extract the data set with male gender only. For instance, we have to extract the data set with higher education with PhDs only, or we have to extract the data set who live in urban area only. So this subset function works. So simple examples that I have provided to you is, for instance, if we want to extract a data set of the first two variables only, you can run this course. If you run this course, it extracts only the first two variables. So let me see. So it extracts the first two variables only. The first two variables are ID and gender. So I have put the row blank. So this is simply the name of the data file, this bracket, then space, comma. Space means please do not restrict the row numbers, only restricts the colons. So the restriction for colons is 1 to 2. So first two variables. So if you want to restrict the rows, so you should first type the range of the rows. For instance, 1 is to 10. This is 1 to 10. 1 to 10, comma blank. So this does not restrict the number of variables, but restricts the number of rows. So it filters the observation from 1 to 10 only. So you can run these commands one by one and see the results in our console to understand how subset function works. So I have provided you a lot of commands, and I will provide you the description of these commands, what these commands do for us. For instance, this command, so the data4 is the name of the data file, name of the subset data file that we want to save. So the numbers in the data file will be only those observations in which wage rate equals 15. So let me run this and look the results. The results are now saved in data4 object that we can see in the environment tab. So up to now there is no object called data4, but after we run this, we can see an object called data4. If you run this, so these are the observations. These are the observations for which the wage rate is just 15. So there are 12 observations, and we have extracted the observations for which wage rate is $15 per hour. So you can run these other commands also to see how the data sets are saved by subsetting them. For instance, this command extracts all the data sets of male and saves them in an object called data12. One more example of subsetting. So one more example from the tdburst package. So subsetting a data can be more easier with the use of this package tdburst. So you should install this package first, so either by typing install.packages, then inside parentheses tdburst, or you can just install it manually by going to the packages tab and clicking the install button. So I have already installed this, and I will bring this in the memory of R. So after you have installed the package, you should bring it into the memory of R by typing library and name of the package. So this package has helpful functions for subsetting data. For instance, this command. So this sign is simply the connecting sign. This sign can be typed simply by pressing Ctrl Shift and M. So we can read this sign as simply by then. So we can read this line like this. So save the data in data 18, which is given by first being the data file into your memory, then select the variable 1 to 3. So if you read this sign, if you write this sign by then, the life will be easier. For instance, the data 19 object will save all the elements from data file. So first go to data file, then select 1 comma 5. 1 comma 5 means first column and fifth column. So if you run this, so first you should invoke the tdverse package in the memory of R, then you can run this command, and then you can loop the object named data 19, and you see that only the first and fifth column are saved in this dataset. So you can see the dataset by clicking the name of the object here too, data 19. If you click data 19, only 2 columns have been extracted and saved in this file. So in this way you can subset the data by using the base R functions, which I have discussed a little time earlier, or by using this tdverse package. So one useful thing here is the data 22 object, which saves all the numeric data. So this is useful while calculating correlation. So if you run this command, this command saves all the numeric data, only numeric data, excluding the factor variables or excluding the categorical variables. It saves all the numerical data or numeric data in data 22. This is useful for calculating regression. So if you look the object, if you see the object data 22, so you can see that it has only numerical variables which can be later used while calculating the pairwise correlation. So you can try these other subset functions also. I have given you 37 examples of subsetting, so you can run this one by one and see what happens, how it subsets the data. So I will next jump to directly, so summary statistics. So summary statistics is used to provide a basic, or to look at the basic summary of the data. So as I said earlier, it provides us the 5-point summary. So if you write summary function, summary, and then name of the data file, it provides the 5-point summary of each variable separately. So for categorical variable, if you have declared that so and such variables are categorical variable, and if you have declared them factor, it will simply count them, and for numerical variable it will provide 5-point summary for us. So if you want to look at output by restricting digits, you can use the digits option also. So if you want to see a summary of single variable, you can type the name of the data file followed by $, and then followed by name of the variable for which you are interested. For instance, if I want to look at the 5-point summary of wage rate only, so I can run this command, data file $, name of the variable. So it shows the 5-point summary of wage rate only. So the minimum wage rate is $2.1 per hour. The maximum wage rate is $120.2 per hour. And there are other statistics: first quartile, median, mean, third quartile. So the 5-number command also provides us the same 5-point statistical summary, but without the name of the statistics. So you can calculate the mean, maximum, minimum by using these functions. To calculate variance, you can use the VAR functions. To calculate standard deviation, you can use SD function, then name of the data file followed by $, and name of variables. And if there are missing values, you should use this option, not available, remove equals to true. So this removes the not available observations and calculates the statistics from the rest only. So the summarize function can be used by installing the PSYCH library. It has some nice output of statistical summary. For instance, I have installed this package in my computer and I invoke this to our memory and I summarize the data file. So it has some nice output. For instance, the the rows the rows number of variables, then followed it by their summary. So the summary, uh, number of observation, mean, standard deviation, median, trimmed mean, also minimum, maximum, and range. So the only problem is that even for the categorical variables, it calculates the statistics. So gender is categorical, but it has calculated a standard deviation, it has calculated mean for that. So the problem with this package is that it does not differentiate between numeric and factor variable. For numerical variable only, we can use this, and it produces some more output than the simply summary function. So you can summarize the data set either by using summary functions or by using this package. So if you want to calculate simply mean only, you can use this sapply function. So the sapply function calculates mean for every variable. If we type mean here, if we type median here, it calculates median for every variable. But the problem is that data file has numeric and non-numeric variables or categorical variables. And if you run this command, it says that the argument has non-numeric values, so I cannot calculate. So for that, you can only use the numerical variables only. So I have pulled the numerical variable only and saved them in an object named data22 just few minutes before. So I cannot use this with the data file object, but I have subsetted the data and saved it as data22, which is numerical variables only. I can use this with this data. So this calculates the mean of all variables by ignoring the missing values. The second command, so in the R script file that I have provided to you, there may be data file only in all these commands. So you should first create a subset of data22 that has numerical variables only and replace the name data file by data22 or any other object that has numerical variables only. So you can run these commands and look at the statistics, different statistics. So then I will skip to tables. So in R, the table command provides us the table. For instance, if you write table, table, and then you should write data file, name of the data file, then $, gender. So since R can work with many data files, you should specify the name of the data file first and then followed it by the name of the variable. So we tell R that the gender variable is in data file object, so you should table this variable. So it tabulates male and female, equal number of male and female. So if you want to produce two-way tables, you can simply type table command and the two variables that you want to tabulate. So here you can type the name of the variable as the name of the data file, followed it by the name of the variable, comma, the name of the data file dollar, followed it by name of the variable. So the first variable, comma, second variable. So both these are categorical variables. So if we type this, it will produces the table gender by education type. So the table command works basically to produce tables. So I have provided you a few commands to produce tables. For example, The two-way table command is here. uh, so you can add margins and do some other statistics. And another command is xtabs. Xtabs command is also used to produce tables. Xtabs is the function name of the function. Then inside parentheses you should put this tilde sign, which is just I think left to the number 1 in your keyboard. Then the first variable gender, second variable education type in our data set. So if you run this, the same table appears, and you can try these other functions also. So the f table function is also used for producing table. F table is the R function. Then inside parentheses the name of the variable, followed it by tilde sign, the name of the second variable, and you can produce the table of gender and region. So so you can try these other tables also. And then I will skip to graphics. So we can produce beautiful graphs with R. There are some basic functions in R and some packages that can be used to produce graphics. uh, for instance, we can use the categorical variable to produce bar charts, pie charts. We can produce scatter plot for numerical variables. We can produce box plot for numerical variables. So you can produce those charts with the base commands or by using some package. So the most useful package for this is ggplot, which I have used here, and I will show examples by using that package. For instance, for categorical variable, if you type simply plot and name of variable, so you can just write here data file dollar gender. It will produce a simple bar diagram in R that can be seen in the graphics tab. So you can zoom this graphics tab by simply pressing Ctrl Shift and 6. Ctrl Shift and 6. If you press those buttons simultaneously, it will zoom the graphics. And if you press Ctrl Shift and 6 again, it will take it back to the original position. So you can add title by using this title command and inverted commands name of the title. So you can even first make a table and plot the table in the form of graph. So I have created table which has the name count, which is a table of gender, and after creating the table I make a bar plot. Sorry, the object table, this is I have to put here data file $gender, then it will produce a table and it will produce a graph. So you can add the X label, Y label, the title of the graph, so even the label in your bar chart by running these codes. So you can rotate it as horizontal by simply typing HORIZ, horizontal equal to true. So these are all in the commands that I have sent to you, and you can zoom this by pressing Ctrl Shift and 6. So I have plotted a horizontal bar diagram for gender. Since male and female are in equal number, the bars are equal. So now you can try the other other graphics by running the codes. So the only thing you have to remember here is that if I haven't put the name of the data file before the variable, sometimes it can say that the object gender is not found. So in that case, you can do a trick by simply attaching the data set in R's memory by using attach command, attach data file. So if you attach the data file, R will automatically take the variables from this data. So for instance, so edu type, I have not put any name of the data file before edu type. So if I haven't attached the data file, it must say that I cannot find the object education. But I have now attached the data set and this command will work. So this R understands that the edu type is from the attached data set. So it will plot a simple bar diagram of the count of education type. You can put a title by using title function. You can zoom in the graphics and you can save the graphics by export tab here. So now the use of ggplot. So ggplot has a very powerful commands that can produce very nice graphs. So first you should install this package by simply going to packages and then install. So you should type ggplot2 and then install it. Since I have already installed it in my computer, I simply bring it to the R's memory by typing library ggplot2. So if you do not bring this package to R's memory, the commands will not work. So first you should type library and the name of the command. So now you can produce graphics with ggplot. The simple mechanics is here is that in ggplot there are three parts. The first part is the name of the data that you should type. The second part is the aesthetics part, where you provide the x variable, the y variable, the color type, etc. And the third part is the type of diagram. For instance, if you want to create pie diagram, you should specify here. If you want to plot a bar diagram, you should specify here. So three parts. First part is data file, second part is the xy variable and other aesthetics, and third part is the type of the diagram. So geom underscore bar means it's a bar diagram. So if you run this, it will produce a bar diagram by default color. So if you zoom this, you can see a simple bar diagram that is filled with the default colors. So you can put title, you can name the axis, you can change the colors by using the aesthetics function, and you can add others too. For instance, the next command, what it does is that it fills the bars by green color and the border colors are put red. So all these you can put in the geometric function or the last part of the uh, total function. The first part is data file, the second part is aesthetics, the last part is the geometric property. You can specify here what colors you want to be filled with the bars, what colors do you want to be the borders of the bars. For instance, if you run this and if you zoom this, the bars are now filled with green color with red borders. So you can play around with other options too. For example, you can put the name of x-axis, y-axis, and title. You can run this together, and now the bars will come in a different taste, different aesthetics. Now the bars have been differentiated by colors. So we have specified this in the aesthetics part. In the aesthetics part, we have told that x is a gender variable and fill the color by gender. If you specify this fill function in the aesthetics part, it will differentiate the bars by the categories. So gender has two categories, it has differentiated the categories by colors. So you can play around with this and you can plot the bar diagrams of other variables also. For instance, you can plot a bar diagram of education types and other variables. I've provided few examples here. So if there are two categories, the simple function is plot followed by two variables. So this provides a simple bar diagram. So this is region by gender, and you can produce different charts. You can fill the color, and you can put the title so that it looks nicer, and you can plot uh, this chart with the ggplot packages also. So I have provided few examples here. So you can plot bar charts by the bar plot command, and the ggplot example is here. I think there are yeah, the this is for gender, and this is for gender, but now differentiated by the regions. So the same gender bar chart has now been differentiated by region. So out of male, how many male live in north central, how many male live in northeast. So you can produce this with the ggplot package. So you can plot the pie charts also. You can plot the dot charts. For instance, the dot chart command produces a dot chart which looks like this. So you can plot histogram. You can plot histogram by simply using HIST command. So this is the histogram of age. Since the age has only discrete values, it doesn't look nicer like a histogram. So you can plot histogram of wage rate, that may be nicer. So you can plot histogram by using this package ggpubr. So I have already installed this, and I can make a nice looking histogram from this package. So this is the same histogram of age of respondents. So it looks now nicer than the before one. So you can change the color, you can change the title, etc. So the scatter plot, for plotting scatter plot, simply we use the plot command, the dependent variable, sorry, the x variable followed it by the y variable, between them the tilde sign. So this produces a simple scatter plot. So you can change the color, so you can name the axis by simply using these commands. So inside the inverted commas you can change the name of the title. xlab, inside inverted commas you can change the name to be appeared in x-axis. You can change the color, etc. So if you want to plot a fit line in the chart, you can use the ab line command. So it will fit a linear plot, a linear line in the same scatter plot. So you can produce a scatter plot with other packages also. For instance, the CAR package produces a nicer scatter plot. So the same scatter plot now in a nicer mode. So you can change the colors, you can play with around, so that you can add some beauty to the scatter plot. So the box plot, you may have heard about the box plot. Box plot simply plots the quartiles, the minimum and the maximal value, and the median. So you can produce a box plot by using simply box plot command. So this is the box plot for wage rate, the minimum value, the first quartile, median, third quartile, and maximum value. So you can produce the box plot with box plot command, and you can use the ggpubr package to produce box plot, and you can fill the colors, you can play around with these functions. So you can plot the QQ plot by using the QQ plot command, and you can produce the line plots also by using the commands that I have provided to you. So now I will skip to correlation analysis. So the correlation analysis measures the relationship, the strength of relationship between variables. For instance, there may be some relationship between the years of education and the wage rate. So we want to know whether the relationship is positive or not. If the relationship is positive, how strength has the relationship, or how strong is the relationship. So to calculate the relationship between two variables, we can either use Pearson correlation, Spearman correlation, or Kendall's correlation. So in case of numerical variables, the Pearson's correlation is widely used. So one thing to remember here is that if you have factor variables, R cannot calculate correlation for that. So for instance, in data file, there are some factor variables, and R cannot calculate correlation for that. So for instance, if we try two variables, these two variables are both numeric, R can calculate this because both are numeric. The command is COR, inside parentheses the first variable comma second variable. And if you want to specify options, you can specify by method equals to inside inverted comma the name of the method. So this will provide the Pearson's correlation. The second command provides the Spearman's correlation. The third one, Kendall's correlation. We see that all are positive and the value is a little bit lower. So we can say that years of education and wage rate are positively related, but they are not strongly related. So now if you want to plot, or if you want to calculate the pairwise correlation for all possible variables, for instance, you have 10 variables which are numeric and you want to calculate correlation for each pair of the variable, you can use the command pairs, but the only requirement is that the data file must have numerical variables only. For instance, I had saved a few minutes before a data file that had numerical variables only. The name of the data file was data22, if you remember. So now if I want to calculate the pairwise correlation among all the variables in the data set, I can simply I can simply I can simply use the COR command. So I will enter here. I will use simply the COR command, COR, and then data22. So I know that data22 has numerical variables only. So if you press this, it will calculate all the pairwise correlation. Pairwise correlation means it calculates the correlation between years of education and age, years of education and years of education, years of education and ASVABC, which is a cognitive ability score. So all correlations between the variables. So the if you want to round off these numbers, so you can use the round command. For using the round command, you can simply type here round, then correlation there 22. So first you can use round, then correlation there 22. Then you can specify the name of the digits. Comma 2 means it will round off to 2 digits. So if you run this, it will produce the same correlation matrix, but the correlations now rounded off to 2 digits. So the only thing to remember here is that if you want to produce all pairwise correlation, your data subset must have numerical variables only. If you want to find a correlation with a data set that has numeric as well as character variable, for instance, I try correlation, then data file. I know that data file has gender, which is not numerical variable. So if you try this, what it says is that there is an error because there are some non-numerical variables. So, so the point to be noted here is that if your data has string variable, if your data has categorical variable, or if your data set has non-numerical variable, you must make a separate data set that contains the numerical variables only, so that you can calculate all pairwise correlations. So now I will move to the next one, the scatter plot. The scatter plot that I have discussed can now be used to produce a scatter plot of all the variables. For instance, the pairs command, which is the R's basic command, it produces a scatter plot of the variables years education, age, wage rate. So let me try. If I pairs, then data 22, pairs and data 22. So it says that margins are too large. If such error comes up, you should enlarge this plots part. So now I think it can produce. Again, it is saying that margins are too large because it has many variables. Producing a scatter plot in a single plot may not be possible. So let me try again. So if there are a lot of variables that you want to plot, the results may not come up in your graphics part, or it may say that margins are too large. So now let me try this. There are only 3 variables. It may be faster to plot this. So if you run this, sorry, I have defined colors first. So it plots the scatter plot of 3 variables together with years of education and age, scatter plot between years of education and age, scatter plot between years of education and wage rate, and scatter plot between age and wage rate. So you can plot all the scatter plots in a single graphics. So I have written a function here to plot the correlation coefficient as well as the scatter plots. So you can try this. Sorry, the command is not complete. So you can try this and look at the charts that has scatter plots as well as the correlation coefficient. So the correlation coefficient, for instance, between age and wage rate is 0.01. The correlation coefficient between wage rate and years of education is 0.42. So you can see a scatter plot as well as the correlation coefficient. So you can play with these formulas, with these commands to see what kinds of pair scatter plots can be produced with R. So there are a few other commands that I've provided to you. You can try those ones. So the last thing that I'm going to discuss today is about hypothesis test. R can carry out all the hypothesis tests that we want to do. I'll discuss the t-test, students t-test, then chi-square test, and then ANOVA test. So I've provided you the commands with other tests also, but you can try those if you understand the basics of the hypothesis test. For instance, the t-test can be used to check whether some variable has a specified mean value or not. For instance, you can check whether the wage rate is $50 per hour or not. So for this, the variable should be numeric, and we want to check the mean value of the variable to be a certain number or not. So to carry out the t-test, the command is t.test command. For instance, this what this line says is that t.test means we want to carry the t-test and we want to check whether the mean age is 50 or not. So to check that, you should write t.test, then inside parentheses the name of the variable, comma, the mean value equals to 50. So R will understand that you are going to check whether the mean value of the age is 50 or not. So in this case, uh, you can first attach the data file again. You can attach the data files for the R to understand that we are working with this data file. So attach inside parenthesis data file. Now you can do t-test. You can do t-test to check whether mean is 50 or not. So I won't go in detail about how to interpret the results. The only thing is that you should look at the probability value. The probability value, if the probability value is less than 0.05, we reject the null hypothesis. The null hypothesis here is that the average age is 50. So since the p-value is very small here, so this is in scientific notation, this means that there are 15 zeros. There are 15 zeros after the decimal. So this is 0.000, 15 zeros and 2. So this is a very small number, almost 0. So since this is less than 0.05, we reject our hypothesis that the average age is 50. So you can change this number to be 40, and you can again check this and see the probability. You can change this number to 37 and see the probability. If the probability is less than 0.05, we should reject the original hypothesis that we have made. So this default t-test function uses the t-test as the two-sided t-test, and at the confidence interval 0.95 or 5% level of significance. If you want to change the level of significance, you can change. For example, if you want to conduct a left tail test, you can type less instead of two-sided. And if you want to change the confidence level, you can type 0.99 if you want to take 1% significance level. So you can play around with this and see whether you can reject the hypothesis or not. So you can change the numbers, you can change the type of test, you can change the confidence interval, or you can change the level of significance and see the results. So now for two independent groups. Now, for instance, if you want to test the hypothesis that the mean wage rate of male and females are equal or not, so you can use t-test to test this hypothesis. So now our concern is whether the average mean or whether the average wage rate differs between male and female or not. So you can test this by simply typing the t-test function, and inside parentheses the numerical variable, which is wage rate, this tilde sign followed by the categorical variable or group variable. So we want to test whether the wage rate differs among male and female or not. So t-test inside parentheses wage rate tilde sign, then group variable. So if you run this will run a t-test to check that the mean difference is 0, or the difference between, or there is no difference between the average wage rate between male and female. So again, we will look at the p-value. The p-value is very small number, the very small number, almost 0. So if this is a very small number, we reject the hypothesis. So in this case, our hypothesis always is that there is no difference between the wage rate between male and female groups. So the male and female groups have same average wage rate. So that is our null hypothesis. So since the probability is very small, we reject the null hypothesis and conclude that there is indeed some difference between the wage rate of male and female. So again, you can change different specification. For instance, you can change the confidence level. You can change the confidence level. You can conduct a one-tail test. Even you can specify whether you want to use equal variance or not. So if you feel that the variance between male and female wage rate are different, so you can use false here, and it will produce a t-test for unequal variances by assuming that the variance among male and female groups are different. So you can play around with this and see the results. So you can change two-sided to less or greater to do a right tail and left tail t-test. Then another t-test, which is the pair t-test. So I want to spend few minutes on pair t-test. The pair t-test simply is used when the data are collected before some treatment and after some treatment. For instance, uh, during this COVID crisis, students are taught through online classes. So we want to check whether giving online classes is effective or not. So we must have the data for each student before the online class starts and after the online class. So we can record the score when there was no online class, and we can record the score after the online class starts. So we want to check whether the online class is effective or not. So that is called pair t-test. For that, we do not have the data in this data set, and I have created hypothetical data set and sent to you. The name of the data is ttestdata.xlsx. That is in the working directory. If I forgot to send this data to you, I will resend it again. So I will import this data set, and I will do a t-test. The same function t.test, then the name of the first variable, which is group A, the name of the second variable, which is group B. So, and alternative is two-sided. Sorry, this data is for independent groups. Sorry, the appropriate data is the second one, which is t-test data XLS. The seeds are different. Sorry, the seeds are different. For the seed for independent groups is in independent seed, and the pair t-test data are in paired seed. So these are the name of the seeds in Excel file in the working directory. So I import the t-test data for pair t-test. So that has marks before online class and marks after online class. The name of the function is t-test. The only difference is that we have to keep an argument that paired equals to true. Paired equals to true. This is the extra argument. If I run this, the results will show up. Now the null hypothesis for this test is that there is no difference in the score before and after online class. So the null is there is no difference between pre-online class and post-online class. Since the probability is less than 0.05, we reject the null hypothesis that there is no difference between free online and post-online class scores. Or we reject the hypothesis that the online class is not effective, and we conclude that online class score differs from without online class scores. So to test whether online class has increased the score or decreased the scores, we can do one-sided t-test by simply changing the two-sided to less or greater here. So now let me move to chi-square test. The simple chi-square test to check the independence between two categorical variables. So this test is used if we want to check the association between two variables which are categorical. For instance, in our case, gender is categorical variable and education type is categorical variable. If we want to check whether gender and education type are related or not, for instance, being a male is related to getting technical education, being female may be related with taking uh, some nursing education. So we want to check whether gender and education type, which are categorical, are associated or not. So to do the chi-square test, we should first tabulate them, tabulate the categorical variables, the two-way tabulation. We can look at the tables. So the table shows the simple frequencies, the two-way contingency tables. So we can plot a bar and we can carry out a chi-square test by chisq.test command. So no packages needed to be installed for this. This is the base R function. So chi-square test, inside parentheses the name of the two-way table. So for this we first generate a table and save the table by giving some name. So we can give any name for this one, and then chi-square test, inside parentheses the name of the table. Okay, so if I run this chi-square test command, okay, it may come up with some warnings and it may give some probability values. Again, we have to recall the null hypothesis in chi-square test. The null hypothesis in chi-square test is that there is no association between the two categories, or there is no association between gender and education type in this case. So since the probability value is greater than 0.05, since the probability is greater than 0.05, we cannot reject the claim. We can reject the null that gender and education type are not related. So here, since the probability is greater than 0.05, we cannot reject the claim that gender and education type are not related. So a warning message has come up here. The warning message says that chi-square approximation may not be correct. So if we recall the basic criteria to be fulfilled for chi-square test, one criteria is that it may not be valid in small samples. Another criteria is that in 2 by 2 contingency table, the expected frequencies should be greater than 5. So if any of those conditions are not fulfilled, you may come up with this message. In that case, the chi-square test may not be appropriate, and you can carry out Fisher's test. The Fisher's test command is fisher.test, fisher.test. So if you, sorry, I haven't made a table. I can specify the name of the table as table 1 that I have created. So if you carry the Fisher's test, the Fisher's test is valid for small samples, and it is valid even if the expected frequencies are less than 5. So the probability value is greater than 0.05. Again, the same conclusion that gender and education type are not related, or there is no association between them. We cannot reject that claim. So in this way, we carry out the chi-square test or the Fisher's test to check the association between two categorical variables. So finally, the ANOVA test. The ANOVA test is used if there are more than two groups. For instance, in the gender group, there are only two, male and female, and we can use t-test to check the difference in wage rate between them. But suppose that the reason variable has 4 groups in our data set. So in case of 4 groups, we want to check whether the wage rate differs in the 4 categories. The 4 categories in the data set are west, northeast, south, and north central. Now we want to check whether the wage rate differs in these 4 regions or not. So if we have more than two groups in a variable, the t-test cannot be used. In that case, the ANOVA test can be used. So ANOVA test is similar to the t-test, but it is useful when there are two or more than two categories, two or more groups. So if we want to check whether the mean differs between two or more than two groups, ANOVA test is useful. So in this case, the command is AOV. The command is AOV. AOV means analysis of variance. So the command is AOV. We should first type the name of the variable that is measured in numbers, wage rate. So we want to check the difference in wage rates, then tilde sign, then the name of group variable, which is region, that has four categories. And if we hit control and enter, the answers comes up with here. So this answer doesn't show probability. So to see that we should save it as an object. For instance, I save is a test equals to this test function, and I read on this. Now the output of this test has been saved in an object called test. Now I want to summarize this object test. So it will now show the probabilities of the test. So in this case, our hypothesis is that the average wage rate does not differ among the regions. Whatever the region, the average wage rate is same. Our null hypothesis is that one. So our test statistics shows that the probability for that null is less than 0.05. So we reject the claim. We reject the claim that the wage rate is same across all the regions. So it may indicate that the wage rate is different among the regions. So I will stop here. There are some other commands for other tests, for example, for normality test, for some non-parametric tests, Wilson's test, Wilcox test. I have provided you with the course you can try, and I have provided you the course of carrying out regression in R, how to summarize the regression model, how to create the plots of regression model, and how to run the regression model in different transformed variables, for instance log transformation. And I have even provided how to export the regression output to Microsoft Word and any other word processing packages. And I have provided you codes with how to use dummy variables in regression, and even the course of how to carry out logit and probit models in R. So I will stop here. I again emphasize the fact that R is not a software to be learned in a single hour or 2 hours. If you keep interest in R, and if you play around with this course, you can learn the basics of R, and then you can build off in this course and learn about other tests, other graphics. R has more than 5,000 packages. You can choose the appropriate package for you, and you can work and build your knowledge on R further. So now if you have any questions that I can answer, you can put in your chat box, or you can even ask me. I'm not a proficient in R. I may not know all the things. I may not address your query, but I will try to address as far as I know them. So now if you have any questions, I will pick up any questions from the chat box if there are any. Otherwise, we will go for the closing session.